Welcome back guys to the channel. So in this video we are going to find the most luminous star by using the Stephen-Boltzmann's law. So for understanding the Stephen-Boltzmann law, you first have to go through the documentation. I will provide this whole documentation in the description and you can just simply go through it and you will can find that what we are doing here. Okay, all the formulas we are going to define it from the same documentation. And for this video we are going to calculate the luminosity for different set of stars which we have taken in the end. Okay, so let us start this video and let us start coding in Python. Okay, so first we are going to import pi from math module, and then we are going to import this sigma, which is a constant for Stephen-Boltzmann. Here the value of sigma is given as 5.6 and this, so we can import it as it is an inbuilt function for SciPy constant. And then we have defined a luminosity function which takes the value of r and the effective temperature. So r is the radius of the body or the star, and T effective is the temperature. Okay, so here we have given the pseudo data for this, so where signify radius in meters and temperature, right? So this is going to be the pseudo data, and if you want let me show you that how can we access this. So so after that we have defined the area as 4 pi r square as the area, and here we are defining this formula actually L. Okay, luminosity formula, and then the defined function where it's going to return a times sigma and T effective raised to power 4. So as we have given the pseudo data, so we can access the pseudo data of luminosity by giving the help function. So it has displayed us this data which we have given in pseudo form. Okay, so the value of luminosity is going to be in watts. So we are going to apply it for the sun first, then we are going to apply it for the other stars as well. Okay, so first we are going to import the stupidor constant, and from there we are going to import our star radius of sun and the L sun. L is going to be the luminosity, I think. No, we have taken the temperature, sun temperature, which is the effective temperature, and L is the distance. Okay, which we are going to take at a constant. Okay, we are going to use this as a relative value for other stars to compare. So we have calculated the luminosity by applying these all functions and all, by putting the value for of this sun into the R luminous function, and we have got that answer. So this solar luminosity came out to be 3.844 10 to the power 24 watts. So this is by Stephen-Boltzmann law, and according to the standards given by the IAU 2015 revolution B3. So this is also the same value, hence we are on the correct path, we are on the correct track. So after that we are going to define it for some more complex, or you can say we have a compress the all of this above data into this small cell and have given the answer for this. Okay, so this is simple. We have just done the same thing. Okay, so as we have known the value for luminosity for sun, now we are going to calculate it for other stars. So here we have defined another function which is we have defined another argument which takes the value for the R and T as we have as the luminosity, and we have called it as stellar parameters. Okay, so we have given it the as a pseudo data, and it is going to return the R and the T effective value, and going to use it for calculating the luminosity. So here we have taken these 5 stars, and you can take n number of stars and calculate the luminosity for them. Okay, so all this data which we have given in the stars stellar parameter, you can find it easily on NASA site, or maybe on the Google. By giving it a simple Google search you can find this. Okay, and you can use it for n numbers of stars. You have just want to reproduce this data, you can just reuse this code and put on your data as well. Okay, so after calculation we have find out that we have get the relative stellar, we have get the relative solar luminosity for the stars, and the according from our analysis we get that this last star has been the most luminous of the all, with a luminosity of 4.8 10 to the power 31 watts. It is in comparison with what? The sun. Okay, so it is this time more luminous than our sun. So it is considered as one of the brightest, one of the most luminous object in the sky. So that's all for this video, and for the documentation you should go to the description and firstly go through that, then you can watch this video. And and that's all for this video, and if you have any doubt drop it down in the comments, and let's see you in the next one then. Bye.